Steganography is a technique used to hide your secret message inside some kind of media like audio or image or a video. So I wrote a program in MATLAB which can be used to hide your secret message inside an audio or an image. The technique I used is called LSP replacement. So what it does is it replaces the least significant bits of some of the pixels in the image with the message bits. What it does is it might change the least significant bits of some of the pixels in the image, which is quite negligible. So the change is quite negligible and cannot be detected by the human eyes, and your message can remain secure. So here's the program, and I run it. So we have a lot of options over here. I just go ahead and select an image for us. So this is the image in which I want to hide my message. As you can see, this is the original image, and I'll hide a message in that. Okay. I need to specify the file name to store the processed image. So let's say it's rows processed.bmp, and a code. So this is the key which is supposed to be known to the person who wants to retrieve the message from the image. So I'll say it's 4444. Okay. We can actually look at the modified image. You can see it's the same as the original because the changes are very small and negligible. So I'll go ahead and retrieve the message from the image. Okay, here's the code, and this is our secret message. I can also hide a text file inside an image. So I've created a small text file for this demo. So let's say this is the text file which contains the message that I want to send secretly. So here's the text file, and the name of the file, let's say, was containing text file .bmp, and the code, let's say it's 3434. So we can compare the two images, rows containing text file, and we can see that these are identical images. They look the same. And let's go ahead and retrieve the message from the image. And this is the message, the one that was stored in the text file. Okay, we can also hide a message inside an audio. So I'll just select one of the WAV files. This is the original audio, and now we'll hide some message in this. This is how, let's say, we save it as watermark.wav file, and let's say it is 5454. Okay, so now I'll retrieve the message from the sound, and yeah, this is the modified audio and the key. So this is our secret message. We can see that there is a negligible change in the audio. We can compare them. Yeah, there's a slight glitch in the second one, and the reason is that instead of storing it in the least significant bit, I'm modifying all the bits of one of the sound amplitudes in one of the streams. So this is the disadvantage of not using a least significant bit and using all the bits instead of any of the amplitudes. So this is how steganography works. The problem with LSB steganography is that the encryption is done in the spatial domain. So you know, if say for example your entire bit plane is destroyed, your message is lost. Another way of doing steganography would be to use do it in this frequency domain. So we can take some kind of discrete Fourier transform or discrete cosine transform of the image, and we can modify the high frequency components without worrying about the image, because that renders changes to the image which can't be detected by the human eye. So we can change the high frequency components and place our message bits over there, and we are still fine. And the changes in the frequency domain are spread across the image in the spatial domain, so it's very difficult to detect. And so yeah, I guess that's it. Thank you for watching.